Hello, my name is Jonathan Sharples. I'm a professor in oceanography at the University of Liverpool. What I'm going to show you here is a small model of the circulation in the entire Atlantic Ocean. So think about that side of the Atlantic is the equator. This side of the North Atlantic is up in the Arctic Ocean. So this is our sunshine here, really strong sunshine at the equator, and we're going to have really cold water up here in the Atlantic, North Atlantic. So what we're going to be showing you is how that cold water becomes very dense and sinks into the bottom of the Atlantic, moves along towards the equator, and the heat at the equator warms up that surface water, which moves north towards the North Atlantic, where it then cools down. So it sets up this whole circulation across the entire basin. So we've got some ice here for the Arctic. There's a bit of blue food colour in the ice just so that we can see where the water goes, where the cold water goes. And you can immediately see as that water starts to melt, it's still cold water with the food colour, it's sinking down into the bottom of the North Atlantic, and it will start to creep along the seabed of the Atlantic. At the same time, hopefully this works, I've got some red water which initially it'll sink, but it'll start to come to the top because of this heating, and we should start to see the return circulation at the top. You can just see a very thin layer of the return circulation. And this deep water now, this dense cold water sinking down to the bottom, is clearly creeping along the bottom. You can start to see the return flow of the water in the surface. Just keep the cold water stocked up. There, so that warm water heading towards the north, that'd be like the Gulf Stream. So the Gulf Stream takes warm water from the Gulf of Mexico up past the northeast coast of the United States, up into the Arctic Ocean, where it starts to cool, and you'll start to see that red water start to be drawn down into the blue water there as it cools down and becomes dense and starts to sink into the bottom layer. And the blue, that cold water is creeping along the bottom here, and you can see it start to come up at the equator as the warm water is moved and drags that water up from the bottom of the ocean. So that circulation is going on all the time in the Atlantic Ocean. It takes a long time. The sort of time scale for that whole overturning to happen is hundreds of years, and it's really important. And one of the reasons why it's so important is that this cold water, as this water becomes very cold in the Arctic, cold water holds more gas. That cold water in the Arctic absorbs carbon dioxide from the atmosphere, and it holds onto that carbon dioxide and takes it down into the deep water and locks it away from the atmosphere for the time it takes the whole circulation to turn over, for centuries. So that is always going on in the Arctic, is that cold formation of water soaking up CO2 from the atmosphere and taking it down into the depths of the Atlantic and along the bottom of the Atlantic Ocean. Of course, in a few hundred years it will start to come back up at the other end, so you end up with that relatively high concentration of carbon dioxide coming up to the surface. But at the moment that's not thought to be too much of a problem, because we're putting CO2 into the atmosphere so quickly. There'll be so much CO2 in the atmosphere it won't be able to be released from the ocean when it gets back up to the surface.